6-5, Linear Inequalities. To graph linear inequalities in two variables, to use linear inequalities when modeling real-world situations. Linear inequality in two variables, such as y is greater than x minus 3, can be formed by replacing the equal sign in a linear equation with an inequality symbol. A solution of the inequality in two variables is an ordered pair that makes the inequality true. Essential understanding. A linear inequality in two variables has an infinite number of solutions. These solutions can be represented in the coordinate plane as a set of all points on one side of the boundary line. Problem number 1. Identifying solutions of a linear inequality. Is the ordered pair a solution of y is greater than x minus 3? So we look at A. The ordered pair is 1, 2. So we put 2 in for y, 1 in for x. 1 minus 3 is negative 2. 2 is greater than negative 2. Check. This is a true statement. So the ordered pair 1, 2 is a solution. B. Negative 3, negative 7. So we're checking to see if this ordered pair is a solution. So negative 7 comes in for y, negative 3 goes in for x. Negative 3 minus 3 is negative 6. Negative 7 is greater than negative 6. And no, that's not a true statement. So we have an X here saying no, that's not true. So negative 3, negative 7 is not a solution. The graph of a linear inequality in two variables consists of all points in the coordinate plane that represent solutions. The graph is a region called a half plane that is bounded by a line. So if we look here, we have a line that's dividing the graph in half. So there's your half plane. That's what they're talking about, half yellow, half white. All the points on one side of the boundary line are solutions, while all the points on the other side are not solutions. So we have y is greater than 2/3 x minus 1. That's this line. And it's dashed because there is no equal sign here. So what's on the line doesn't work. But everything on this side that's yellow works. And then we look over on this side. Y is less than or equal to. So now we have a solid line because we have an equal sign right here. And then less than, so we're on the bottom half. If you look over here, it said y is greater than. So we picked above the line. But this one says less than, so we're picking below the line. 2. Graphing an inequality in two variables. What is the graph of y is greater than x minus 2? First, graph the boundary line y is equal to x minus 2. Since the inequality symbol is greater than, the points on the boundary line are not solutions. Use a dashed line to indicate that the points are not included in the solution. To determine which side of the boundary line is shaded, test a point that is not on the line. For example, test 0, 0. Now remember, we always make our math really easy when we have a choice of what we're going to do. And so if we look over here, 0, 0, the origin is in the solution side. So we put zeros in for x and y. So here we have 0 in for y, 0 in for x. So 0 is greater than negative 2. So 0, 0 is a solution because we check. That is a true statement right here. Because the point 0, 0 is a solution of the inequality, so are all the points on the same side of the boundary line as 0, 0. Shade the area above the boundary line. Inequality in one variable can be graphed on a number line or in a coordinate plane. The boundary line will be a horizontal or vertical line. Graphing a linear inequality in one variable. What is the graph of each inequality in the coordinate plane? So here we have x is greater than -1. Graph x is equal to -1 using a dashed line. Because we come back to the original, it is not equal, it's only greater than. Use 0, 0 to test this point. So we want to know, are we going to shade this side or this side of the graph? So we put 0 in for x. 0 is greater than -1, so we know the origin 0, 0 is going to be shaded in. So we shade on that side of the line that contains 0, 0. B, y is greater than or equal to 2. So we graph y is equal to 2 using a solid line, because we come back up here to the original and we see y is greater than or equal to 2. And now we're going to use 0, 0 as a test point. So we put 0 in for y. Y is greater than or equal to 2. And we X that out. That's not a true statement. Shade on the side of the line that does not contain 0, 0. So here's our origin, 0, 0. We go to the other side of the graphed line and shade it in. When a linear inequality is solved for y, the directions of the inequality symbol determines which side of the boundary line to shade. If the symbol is less than or less than and equal to, shade below the boundary line. If the symbol is greater than or greater than and equal to, shade above it. Sometimes you must first solve an inequality for y before using the method described above to determine where to shade. Problem 4. Rewriting to graph an inequality. Interior design. An interior decorator is going to remodel a kitchen. The wall above the stove and the counter is going to be redone as shown. The owners can spend $420 or less. Write a linear inequality and graph the solutions. What are the 3 possible prices for the wallpaper and tile? So we're going to let X be the cost per square foot of paper, and Y will equal the cost of square foot of the tile. Write an inequality to solve it for Y. So we have 24x plus 12y is less than or equal to 420. That's the total cost is 420 or less. So you have to stay underneath the 420. So to solve for y, we need to subtract 24x from both sides and then divide everybody by 12. So we end up with y is less than or equal to negative 2x plus 35. And now we can go graph that. So plus 35 says we start here at 35, and then our slope says negative 2. So we go down 2, out 1, and we keep moving on with our slope. Graph y is less than or equal to negative 2x plus 35. The inequality symbol is less than or equal to, so the boundary line is solid, and you shade below. The graph only makes sense in the first quadrant. 3 possibility prices per square foot for the wallpaper and tiles are $5 and $25, $5 and $15, $10 and $10. Okay, so when we go to graph this, we can put in 0 for x, 0 for y, and find out where those two are and draw our lines. And then as we look in here, we can see the $5 comes all the way up to the $25. And then we could also, here the 15 is in there also. And then as we come up on the 10, we also match up with the 10. 5. Writing an inequality from a graph. So we have a multiple choice. Which inequality represents the graph at the right? Okay, so if we look at the graph, we see our y-intercept is at 1, and 1, 1, 1, 1. They're all adding 1. Okay, so we look at our slope. So if I go to the right one, I have to go up 2 before I'm back on the line. Well, they all have a slope of 2 except B. So B is out at this point. That's not even an option. Okay, now we look here and we have a solid line. That means it has to say equal to. So that's A and B. D is out. So we don't have to look at B or D anymore. All right, so the shaded is on the right hand side. We have 0, 0. The origin 0, 0 should work. So if I put in 0 here, the 2's gone, and this says 0 is greater than plus 1. That's not true. If I put in 0 and 0 here, again, the 2 is out, and this says 0 is less than or equal to 1. And that's a true statement. Here it says y is less than, and you can see we are on the bottom side of the line. So the slope of the line is 2, and the y-intercept is 1. So the equation of the boundary is y is equal to 2x plus 1. The boundary line is solid. So the inequality symbol is either less than or equal to or greater than or equal to. The symbol must be less than because the region below the boundary line is shaded. The inequality is y is less than or equal to 2x plus 1.